We'd like to thank the following sponsors for helping provide this video.
Hello? Hi. So, just out of curiosity, how many people were here all day today? And how many people are just showing up for dinner? Well, so you missed out on a great day. I want to talk about Agile. I'm going to talk about practices, and I'm going to tell you a story, quasi-fictional story of a company. But the main goal that I want to do here is talk about what I think is the underlying guidance and principle in Agile. The thing that once I put together, I was seeing this here and I was seeing this here, and once I put together why I was seeing it, just made everything else make a lot more sense for me. We work in a really new industry. We're out in the more rural part of India at a university. We do a lot of work with kids. And we were teaching out there, and they had all around the campus pictures of like the great software people, and they're all alive. Right? Like when you walk around the physics hall, there's like maybe one person who's still alive, right? But all these people, I mean, they're either still alive or they have just very recently died. Like, we are a very new industry, and because of that, we are still finding our feet. And I hope that like a lot of the specific stuff that I talk about today will just be utter, like you will look back in 10 years and say, what was that guy thinking? This is crazy. How little do we know? But I think the principles will stay, and the principles will guide. And so I want to talk about some common practices and guided by this principle. So let's start with a little bit of history. There's not much of it in our industry. But about 60 years ago now, there were computers, and people needed to program them. And so they did. And they just did whatever they could do to program. And so I want to simulate this over the course of a project. This sort of just trying stuff, right? We call it cowboy programming in the Agile world, or ad hoc programming. It gives it much more of a unifying structure than it really has. But I think it's important to do. So here's the way that I'm going to demo this, because I need to take you through sort of a whole project, and I'm going to need to take you through it 3 times in a very short amount of time. So what I'm going to do is I'm going to produce 3 things for my site. I have some money. Every time I get it wrong, it's going to cost me some money. It's going to cost me $0.25. And we're just going to go through this. All right? So first thing is we need a website. So I'm a programmer, I go off, I build a website, I show it to the person, and they are not quite happy, so I have to go back and correct some stuff. That cost me $0.25. I fix those things, I bring it back to them. It's still not working. It's still not working. It's a little bit slow, and we get to a solution, which is cool. But we're not done. We have 3 things we do, so we're going to have a shopping cart as well. So I'm going to go and I'm going to program that. And it's not quite right, or there's little things, or too confusing, or it doesn't quite work. But eventually, we get through that as well. And then finally, we're going to do some recommendation engine. Again, it takes a little bit before we finally get to the thing. And this is good, by the way. If you look at the companies out there that are rich and wealthy, a surprisingly large amount of them are software companies. For something that didn't exist 60 years ago, that's good. This is still cheap, right?
$2.75 is cheap.
$2.75. We'll talk about where the decimal goes later. But it is actually an amazing thing. Even at the cost, they were still cheap. So when they were successful, this was a good thing. But there is that cost. And sometimes the problem is, even if it's cheap, I only got $1.75, so I never get to completion. So people started to say, how can I make them cheaper? And someone came along and said, you know, you're making all these mistakes, and they're expensive. Maybe you could make less mistakes. And out of this, we came up with Waterfall. And Waterfall said, you know, when I plan ahead, I make less mistakes. So now we're going to run this again, but with planning. So we plan and we figure out what it is that I want on my website. And then I go and I build it. And now, well, I mean, it's almost right. So there's a couple mistakes. And I mean, it's close though, right? Good. Okay. That was much better. We're here. Now we have to do the shopping cart. So again, we go and we plan and we figure out what we want. And then we build it. And now, I mean, we get really, really close. And, okay, well, there. Good. Less mistakes. We're doing better. Now we have the recommendation engine. And again, we research it and we plan it. And, I mean, it's sort of, well, okay, people are crazy. But we get there. And now we are cheaper. We made less mistakes, and we got less cost. And this is good. We want less cost. We want less mistakes. It fits what we want, especially as an engineer. And this is sort of where the story might have ended. Except for all of a sudden these people came around from the Agile world. And they said, you know, instead of this planning and focusing on not making mistakes, maybe we just accept that we're going to make mistakes. And instead, I'm going to focus on changing that quarter into a penny. So now I try stuff, and it's not, I mean, it's really not. I mean, I can do some, there we go. Let's try it again for the shopping cart. Well, it's still not, no, I mean, it could be, it's closer. It seems like, well, okay, there we go. What do we do for recommendation engine? Oh, but I mean, it could be, and it's, I mean, people, look, there we go. And look, I'm making all of these mistakes. Tons of mistakes. But my costs are really, really low. I like graphs, so let's take a look at this. We make mistakes, they cost us money. So people say, don't make mistakes. So we make less mistakes, and they cost us less money. And then the whole world changes. And I make a ton more mistakes. But it costs me almost nothing. In fact, it becomes so cheap that if I was to make one mistake, I'd still lose out. This is a hard thing for me as an engineer. As an engineer, I am paid and valued on my intelligence. And I don't like to make mistakes. And so when I first sort of came to realize this, I think I had a similar response to most people, which is, well, what if we could do that waterfall thing and get it down to a nickel? I say, well, 7 times 5 is 35. It's still, the math is not working well. But I think it's worth recognizing that there's an emotional cost for us in admitting that we are going to make mistakes. Nonetheless, this is the core concept that I'm going to talk about for the rest of the talk, which is Agile and all the practices in Agile are about admitting that we're going to make mistakes and saying we want these mistakes to be cheaper, and we are going to do a lot to make these mistakes cheaper. We're going to talk about that. But first of all, it's not magic. In fact, it's really not magic, right? Like, one of the most basic things in Agile is to do 2-week iterations instead of a year, which just so happens is 50 weeks in a year, and 2, it's 25 times cheaper if you're doing the wrong thing. I mean, the way you do this, it's more than just these 3, right? But these 3 are the big ones. First is detection. So I do a lot of volunteer work, and that's not a good place to stand. So one of the things I do is a medical records project in Zambia. So we're down there for a month working with the team down there. And we have a friend, and her mom, she's also volunteering. Her mother's from Los Angeles. And she was coming to visit her. Right? And her mother's kind of older, so I mean she can walk. She's, but she can't walk well. So whenever we go around big distances, she goes around. She uses a wheelchair to get around. And so she comes to visit us, and she leaves the house without her wheelchair. This is a mistake. And had she realized it, and I'm not entirely sure how you don't realize this. But had she realized it as she walked out the door, she would have cost herself 3 minutes as she goes back into the house and gets her wheelchair. But she doesn't. But when she gets to the airport, now she can realize it. And it will cost her a cab ride and the 3 minutes. But she doesn't. She realizes it when she gets to Zambia. And we say, where is your wheelchair? You can't rent the wheelchair in Zambia. So this mistake, the same mistake, by the way, now costs us $500 to buy a new wheelchair. Same mistake. But until you detect it, it's going to consistently get more expensive. Detection's not enough. It also needs to be easy to change once you detect it. So I have a friend, falls in love, gets married, wakes up the next day. Detection was quick. However, at this point, change becomes difficult. And finally, for area of effect, I want to use a story from my own programming experience. I was at a client, and I was working with my pair. Oh, I'm sorry.
I am nervously looking.
And I'm working with my pair, and we're working on the database, and we mess up. We take the database down a little bit. It took us like another 50 or 60 minutes to fix our mistake and get it up and working again. When we did, I heard all these little comments coming from around me. Stuff like, oh, it's working now. It seems to work. So I kind of turn to my pair. I say, everybody working on the same development database? Oh, yeah, the whole floor. All 50 of them. That 2 hours of 2 man-hours that should have been is now 52 man-hours. I would still build a client, but I mean, it's much more costly now, right? It's the same mistake, but what I'm doing is not just affecting me, it's affecting other people. And the more your area of effect is bigger, the more costly a mistake is going to be. So these are the 3 things. We're now going to apply these to the story of Acne. Acme is a fictional company. If you think you know who I'm talking about, I promise I am making it up. Acme is a company that gets what is really, I think, the best deal in software. They get hired by a company to build a product for them. In this case, it's a point-of-sale product. And not only are they hired to build the product, they are allowed to keep the rights to the product, to resell it to companies afterwards. So you are paid for your research and development, you are profitable on your research and development, and you now have a product that you can be all the more profitable when you're done. It's a really good situation. We live in a good industry, in a good time. They're on the East Coast. We happen to be on the West Coast. So that's a little bit of a disadvantage, but it's not a big deal. We fly out to them, And we spent a couple months figuring out really how this system needs to work. We talk to everyone we can talk to. We write up all the requirements that we can possibly think of and that they can think of. And we figure out. And so we fly back and we start building. And at this point, we're still a small team. I think there's 3 or 4 of us at this point. Very small. And it's just all around good. And so we go and we start building. We know that we need to like sort of check with the client. So we set up for a 4-month check. So in 4 months, they fly out and they're going to see what we do. And we work as hard as we can in between there to build a system that they really need, that they'll love. And they come out and we're doing the demo for them. And it's going really, really well. They like what they see. We're proud of what we built. And at one point, one of the customers says, well, how does it handle purchase orders? And we say it doesn't handle purchase orders. You know, we talked about it and you said that this system is cash up front. Everything's cash up. It's much simpler. Purchase orders are much more complicated. You need credit, you need inventory, you need billing, you need interest. It doesn't do that. And he's like, no, we need it to do purchase orders. And we said, no, we asked about this. You told us you never do anything but cash up front. And he says it, and he says it sincerely, in a way that only non-programmers can do.
Of course.
He says, yes, we never do purchase orders except once a year. But they're big orders. They're from the military. We need to handle these. And we try to explain that never and once a year are not the same thing. And they're getting upset, and we're getting upset, and really this is not a good day. Except we have a salesperson. And our salesperson knows exactly what to do. He calms everybody in the room down. He turns to the client, looks them straight in the eye, and says, not a problem, we can do that. So we go back and we start over. So, what was the mistake? Yeah?
Letting the sales guy in the room.
Well, I'm not disagreeing. We're looking at a more fundamental level.
They taking the customer as their word. Right? They will change their mind. They have to.
Well, this isn't even to change their mind.
Yeah, they won't tell you from the beginning.
This is
Yeah, it's common.
a common misunderstanding between never and infrequent.
Right.
Yeah?
Not getting feedback sooner.
Ah, so that's an interesting comment, not getting feedback sooner. So I'm going to put to you that that's not what our mistake is. That might have been a way to help prevent the mistake or reduce the mistake. But it's a second level solution. You're still not getting to what is the actual mistake.
The expectation that you didn't make a mistake.
Or that you understood the word.
So that would be why we might not have detected it.
Yes.
But what was the mistake?
The assumption that you could determine all the requirements up front.
Closer. That's still hubris.
Inflexibility of building something that wasn't going to be have options to change.
So let me try it this way.
Not publishing the report.
Right. That's our actual problem.
What?
We did not understand what the customer actually wanted. If we had understood all these other things that you said, if we didn't make any requirements mistakes, the fact that we didn't get feedback wouldn't have mattered. If we didn't get the things that are hubris that we could have gotten right, would have been fine. The problem is we didn't get it right? And so it seems really basic. And it's so basic, I think, that a lot of times you skip over that mistake.
Yeah.
And you go to the second part. Simply said, we misunderstood what they actually needed. So,
But on the other hand, they didn't understand what they actually needed either.
true. But either way, the requirement is misunderstood. Now you're just placing the who. Yeah. So hold on. So there's like a whole bunch of you in a room and a whole bunch of hands. So I'm just going to have like the shouting out thing because I'm going to not be able to keep track otherwise.
Okay, anyway.
You needed a test.
A business analyst.
Oh, a business analyst. We had one.
Well, what about putting out the requirements and saying, okay, we discussed it, here they are. Are these the ones?
We did that.
It doesn't change the fact that they need it, even if it's not.
But all of these are ways that you guys want to prevent the mistake.
You didn't make the mistake early enough.
Oh, believe me, we did. But yes, that would be the thing. And that gets to our next point, which is how do we make this cheaper? How do we not misunderstand the requirements? But how do we make it so that when we do, they are cheaper? We got 3 things at our disposal. What's the magic one?
Early detection.
Early detection. See, you guys are all good at this. So that's where we did the requirements. This is where we did the demo. Everybody agree that this would be cheaper?
Yes. Cheaper.
Cheaper too?
Go, go,
Yes.
go. Just give a break. Give a break.
So, out of this we get the Agile practice of on-site customer. Now, sometimes this is literally, and ideally this is literally, an actual on-site customer. If you're building software internally, this is very easy to get. Sometimes it's harder, either location-wise or customer-wise, and it translates to just a highly available customer. Someone who's expecting a few phone calls a day, not long phone calls, short phone calls, but a lot of them. Some simple little things. You can be your own customer a lot. Be a little bit careful between a business analyst and a customer. There are different things. We'll talk about that more later. It's not that you don't want a business analyst. It's just you also want a customer. I mentioned trust on here. I should talk about this. I've worked at companies, I don't anymore, but perhaps you do, so it's worth talking about, where there is not trust between the people developing the software and the people using the software, and possibly for very good reason, and therefore adding extra vision into the process will cause a bit of disturbance. My best advice is to change companies, but do be aware that sometimes people are actively trying to keep this kind of thing hidden because they already have a whole bunch of skeletons in a closet that they don't want anything opened. All right, so mistake number 2.
Yeah. The thing with mistake number 1 is you could get the customer input early. Well, you can't get it at requirements, otherwise you wouldn't make the mistake in the first place. But if you get it early on by having the customer there, unless the customer happened to be the one who at the demo brought up the purchase order issue, you're not going to get it. You're not going to get that input. You know, it's unlikely that that particular person is the customer representative.
So in this case, it actually would have been the same customer, but in general, I find that when you talk to someone one time, you're going to get a much more narrow story than when you talk to them frequently. There's much more opportunity for the same person. Everybody, had we gone to anybody at that company and said, do you do purchase orders with the military? They would have said yes. Everybody knew that. What they didn't realize is that that meant they don't always do cash up front. It's like when you try to write out all 50 states, and somehow you only up with 47. It's not that you don't know what a U.S. state is. It's not like someone can come around and say, PepsiCo, is that a state? And you're going to be like, no. It's just recalling them all. It's a problem. The closer you can keep there, the closer you can get detection, assume you are going to misunderstand something. And do what you can to make it cheaper when you do. All right, so I want to go to mistake number 2. So obviously, we do start rewriting, but that's okay. We keep going, and we really had a pretty big pad between what we expected our cost to be and what, how much it would actually cost. So this is discouraging, but it's not like we have to cancel the project or anything. Right? We just keep going, and we regroup, we grow the team a little bit more because this is now a more complex situation, and we rebuild and we infrastructure a little bit better, and we call them out for another meeting, another 4 months. And this time, things are going pretty good. We're on track again, we've caught up. Really, everything's going good except for about a week and a half before the demo goes. I should talk to you about John, our DBA. John's a good guy, he's a good DBA. He'd been a little bit on the geekier side of life, and that had certain social ramifications, but very shortly before we went out, he met just the most amazing woman for him, and he was so happy, and they fell in love, and they fell in love very, very quickly, and they decided it was time to run off and get married. And we tried to explain to John that he can't really go off and get married because we kind of had this demo coming up and we needed the database. Like the whole system kind of doesn't work without the database. But John didn't really care, right? So we told him that if he left, we'd fire him. John still didn't really care. We tried to explain that like marriages don't work on average and maybe should give it some time. And none of this really mattered, and John went off and got married. And good for John. But not good for us, because our system doesn't work without the database.
And you only had one DBA.
Of course we only have one DBA. We only have, at this point our team's still like 8 or 9 people. I mean, one DBA, how many, come on. So we got a new DBA. We got a good DBA. Talented and skilled, but he didn't really understand where the current databases were or which scripts we were actually supposed to run, and the passwords were kind of and you'd think John would answer his phone, but apparently there are other things to do on a honeymoon. And we cannot do anything. The system does not work without a database. And we have this new guy in, and he is working hard, and it is becoming increasingly apparent as this week and a half dwindles down to a few days that we just are not going to be able to demo. And so we make a call to our customer, and we tell them not to get on the plane and not to come out. This is not a good call to make. This is not a call that I would have made if I had had any other options. What's the mistake?
You only had one DBA.
So only having one DBA would have prevented the pain. But what's the actual mistake?
Didn't document anything.
Lack of knowledge?
Siloed knowledge.
Again, would have. Yeah, no, okay, I'll give you a silo. Yeah. We have one part. This is interesting to me because almost every company I work at has this concept of backing up their data and backing up their code. They recognize that this is valuable and that a disk will fail and that it's inevitable that a disk will fail and that the way you prevent that is not making disks that do not fail, but having it on multiple disks so that when one does, you can copy it over. So they understand that the code is valuable, and they understand that the data is valuable. They do not seem to understand that the employees are valuable.
Lack of cross-training.
So lack of cross-training would have prevented our problem, but I mean, let's be clear, like the big problem here is John fell in love. And I said Agile is not going to prevent the mistakes.
Well, if you did extreme programming and you had pairs everywhere.
Just to be extra clear, like Agile will not prevent you from falling in love. But it can help when you do. What would have been the thing here that would have made it cheaper? Change. Just like I have 2 disks, so when one fails, I can use the other one. Swap that into play. If I had had 2 people, I could have swapped that into play.
But it's expensive.
you got to decide. That's sort of like your risk profiles, and you got to look at like how you make your investments, because that's an investment you have to point to say is more important than another investment, and to manage my risk exposure.
So risk analysis and manufacture, yeah. And I could give you the exact same argument on why you shouldn't back up your data.
No, true.
And the cost, it turns out to be very similar. So if it was unbelievably expensive, we would have a different argument. But right now, let's just talk about the practice of pairing. So very specifically, let's talk about the studies, because what you just said is not uncommon at all. So they've done a lot of studies on pair programming and how fast you move on it. And it turns out if you have two people and they're working near each other, they'll get, like, each person will get 40 man-hours of work done in a week. And so at the end of the week, you get 80 man-hours of work. But if you put them both together at the same program, at the same computer, then you only get 80 man-hours out of them at the end of the week. And
40 hours of code.
no, 80. It turns out they don't go faster. They don't go slower. They go the same. And there's good studies. And if you check the stuff from Lori, they go through them in a lot more minutia than I care to go through. But pairing actually ends up being the same velocity. The quality goes up, which is an interesting thing it does. You get about 60% less bugs. But that's not even the part I want to talk about here. I want to talk about the fact that when you pair, you inevitably know things about your system that you would not know otherwise. In fact, even if I paired someone who was not a good DBA with John, he might not have become a good DBA. He would have known where the scripts were. He would have known where the passwords were. He would have been able to take the good DBA that we hired and let him work. Now, over time, he actually will become a good DBA. That's a different thing. The important part here is that for the same cost as running your programmer separate, you can make it so that when one of them inevitably leaves your company, forcefully, non-forcefully, Google's term for it is retire wealthy. A lot of companies call it hit by bus. Either way, you're out of programmer. You need to accept that this is going to happen. You cannot predict when your people will leave. But you can make it so that when they do, it's cheap. So anyhow.
So is John still married?
Actually, he is. It was a good choice on his part, not so much on ours. And the new DBA worked out good too, right? It just it took him quite a few weeks to get up to speed, but once he did, like, he was doing good, and we were doing good, and all around, project is back on track. It's running a little longer than expected. But that's okay, because again, we're still within our buffer. And there was this show in Vegas, Mix. And at Mix, the big show from Microsoft, they announced Windows Phone 7. Really kind of a big thing. Finally, a response from Microsoft to the iPhone that had been sort of dominating the world. Still dominating the world. But they did this demo on stage. It was really kind of nice, where they took a WPF application and live on stage, while we all watched, made it so it also worked on the phone. It was really quite nice that they had this architecture and system that allowed things that would work in your WPF to just almost seamlessly and instantly transfer over to the phone. And
What's WPF?
oh, sorry. It's when you see Windows on your Windows platform that are written in the last 5 years or so, that's what it is. Windows.
Page
Page frame?
Presentation
What they said.
framework.
WPF. So this is great. The problem is, and we knew this right away, is that like the blogs all of a sudden start talking about how important these phones are. And our customer calls us, because he reads the blogs too. And he says, oh God, we got to have this on the phones.
Oh my goodness.
It's got to be on the phones. And he calls the salespeople because they tend to like to talk to them more. And our salesperson says, that is awesome, we're doing that. And so we go, and I want to be clear, the demo that they did on stage is not exactly a lie. But let's say the code was very well suited to go through that transformation. Our code was not as well suited to go through that transformation, and for a lot of reasons. One, I mean, keep in mind, like when we started this, you know, we were learning WPF as well, and we wanted to do a project in it. And we had finally gotten a chance, but we were not experts when we started. We were able to get it working. We learned more as we went, but this code that we worked on the most both started bad and continued to change and evolve and got worse. And had it been these nice modularized, componentized, very MVC things, it would have been really quite easy, I think, to do it. But our code wasn't. Our code was longer methods and maybe a little more intertwined. And anyhow, we had to start kind of pulling the classes apart to even get it so that they could both talk to WPF and the phone. And it started kind of innocently enough with just pulling out one or two, but then the code didn't compile, and then it didn't compile for a while. Then it was kind of 2 weeks before it compiled again. And then once it did compile, it didn't quite work what it was, both on the phones and on the desktop now. It's kind of equal opportunity at this point. And then we realized that this is actually going to kind of require a middleware team and a phone and a WPF team to sort of handle that. So we grew a little bit on our team size here. It was probably about 2.5 months before everything had sort of gone back to where it was before the salesperson said, yeah, we totally have to do that. Yeah. On the plus side, we had a bigger team now. So what was the mistake?
We still have that sales back. Anticipate the technology change.
We didn't anticipate that. Yes, which we would have actually had to be psychic to do. But you are right, we didn't. If we were psychic, we would have been able. We wouldn't have had to worry about the changing requirement. So how do I make it cheaper when things change? Easy to change. So, easy to change. So very specifically here, if my code looked more like that demo code on stage, this would have been a sweet time. Sales guy would have said, yeah, we can do that. We would have done it right away. We would have looked awesome. It didn't. We didn't. But there is this concept called refactoring. And I want to talk about this because I think this is the most misunderstood of the Agile concepts. Almost universally, someone who's never heard of Agile will say, oh yeah, we refactor. Or perhaps they'll use a comment like, I need to refactor it so it does this thing, so it does this different thing, which is not what I mean. What it is that it's about change. It's about saying, I need my code to be in a state of change. And I think Ward Cunningham said this best when he said, the moment I have an insight into the way that I should have written my code, I change it so it looks like I knew what I was doing all along. That's what refactoring is about. A lot of times they're called merciless refactorings. They're small and often. 2 minutes. It's a good size for a refactoring. Not a week. That's most likely something different. 2 minutes is something I don't need permission from my boss for either. I would just as much need permission from my boss to do a 2-minute refactoring as I would need permission from my boss to go to the bathroom. It's just something I can do. And the best thing you can do if you're not doing it right now is look at the automatic refactorings that are in your editor already that will do them on a keystroke. They are really good. They tend to be smarter than you are. And you can replace entire books, notably Martin Fowler's book, with a keyboard shortcut list from most good IDEs. Very specifically is actually written by his book, but they codified it what he wrote. But you no longer need to know what he wrote. You just need to know the shortcuts.
Can you go back?
Oh yeah.
How, I understand 2-minute steps. How much is too much?
Refactoring.
Spending time on refactoring.
Okay, so the question is, how much is too much?
Yeah, assuming a large legacy
So
base.
I tend to do refactorings as soon as I wish the code looked that way, right? So a lot of times I'll sort of write a piece, and then I realize I need something else. I'll sort of copy and paste, and then I'll do a quick refactoring to pull out the commonality. A lot of times that will actually be because I'm about to write the third piece, that would be the third copy and paste. But I do it sort of right before I use it. So my return on investment is almost immediate. So anything that like I can do for 5 minutes, where I can then spend the next 5 minutes and be done in 10 minutes instead of spending 30 minutes, like there's no such thing as too much. The place where it becomes too much is where you're doing refactoring that you are not going to capitalize on for a long time. Right? Where it's like, oh, stylistically, I think it would look better this way so that in the fall, like that's probably the wrong refactoring.
No, but assuming you wrote the code and on the third iteration you're adding a third feature, okay,
That's too long too.
But if a team comes in, existing legacy base, barely working, can't really add another feature because it's going to break too many things,
So if I can't add another feature because it's going to break too many things,
you have to do it.
then I need to refactor enough that I can add that feature. And just from a sort of idea, most of the time we're talking some kind of investment in the neighborhood of a day, maybe 2 days. I will refactor for a day or two, and then I will spend usually less than an hour to now safely add a feature. And I'll be ahead of the 3 or 4 days I would have spent putting something in and breaking it. To do this well, a lot of use of the automatic refactorings, a lot of use of locking tests. That is a completely separate talk. I happen to have it, but we're not giving it today. But however, I am giving an entire course on this on Monday, so if you are interested, show up on Monday. Yeah.
In my experience, it's not sufficient necessarily to be refactored by one person. I've done refactoring on myself, my code, but when you have a team, and the team is working, maybe you have your paired programmers, and they can see refactored together. But that doesn't necessarily mean that the modules were all put together right, that it's only done by just those 2 people.
I think what you're saying is that, like, if I'm in this building and I work on the structure of this floor, but not the other floors, the building might still fall down.
Yes,
Yes.
yes.
Yes, I agree with that.
So I think
So I'm not advocating only one person on your team do refactoring. I am advocating every single person on your team always doing refactoring.
it's cross different modules or different areas of responsibility.
Every person
Yeah, on the project.
always doing refactoring.
But you should, I think you're still missing my point. It's not necessarily an individually designed module or pieces of
The whole team.
The whole team has to be together. So when you do a refactoring or see an insight, then you have your stand-up or some other way of getting together after the stand-up and saying, hey, we've got to look at it and redesign this, this, and this, and this, because I think this is a better way of doing it.
Okay, so the redesign work. Usually the refactorings are smaller. So the thing you just described is not a 2-minute thing. The thing you just described is like a few week thing.
Yes.
What I'm going to tell you, and I'm just going to ask you to trust me on this for right now, is that you can take something that is 2 weeks and chop it up into 2 weeks worth of 2-minute changes that are constantly getting you better. And that the way you actually get clean code is you do these 2-minute things constantly, and then you just look around and it's good code. When you look for, let's get together as a team to spend a big chunk to do some redesign, that meeting never happens, that priorities never happen, and you never get finished. That's not how you do it.
That's why I'm concerned about your example.
Yeah.
Your Microsoft framework. You might imply that it was just a matter of refactoring this module, or your piece of code, that piece of code. The way you described it, it sounded like the whole thing was put together in such a manner that it wasn't a simple thing to be done in 2-minute steps.
No. What I am sorry, so just to be clear, what he's saying is it seemed like, hey, we have this big mess and then we spend 2 minutes and it's clean. That is not what I'm advocating. What I am advocating is when this came up, we are now 8 or 9 months into development, that we should have been doing 2-minute chunks over those 9 months constantly so that when something came up, our code would have been modular. We knew what MVC was, we know what clean code is, we know what separations of concerns are. Had that shown up in our code, we would have been okay. It's not a one-time thing. This is a constant thing. This is eating right and exercising over go to the doctor for liposuction. This is a lifestyle way of doing it. And this is why I say I think this is one of the most misunderstood concepts in Agile, because everybody does redesign, everyone does rewrites. Yeah.
I'm not sure if we're talking about the same thing. I kind of think I hear you talking about trying to adhere to the principle of isolation in architecture, where you put the thing that may need to change in the future, not scattered or strung throughout your code, but in a place where you can easily locate it, isolate it, fix it, replace it, and you haven't tampered with much other than the interface around it.
So that's not all of good design, but it's a big part of it.
Okay.
Yes.
The problem is that you never go, I mean, in your case, you started fresh. So when you start fresh,
In this particular case, I start fresh. Most of my life is spent in not fresh. I was just on a project in Fortran for nuclear silos. Those are not fresh programs. Like, those are horrible programs.
So there, refactoring is not 2 minutes. I mean,
No, it is. It's still 2 minutes. So when I come into a program like this, right? So here we're in Fortran. It's ugly. It's millions of lines of code. It takes forever to compile. I cannot sit there and say, okay, how am I going to refactor this so it's all good? I sit there and I look at a single method, and I say, oh, this method is 20 lines and it's doing the same thing twice. I can pull it into 2 methods that are now 10 lines and 2 lines. And now I've reduced a little bit of complexity there. And I still have 1 million lines of code. That is nothing to my project, but it's 2 minutes and my code is better. And now I go on, and probably in the course of like 5 to 6 minutes, I will get another 2-minute chunk. And it is lots of little changes.
And in 10 years, you'll probably get to the bottom of it.
In 10 years, I will have beautiful code.
Right.
But in 3 to 4 months, I will have code that is not nearly as ugly as it was before. And in 5 to 6 months, I'll have code that I can work with. And usually by 7 months, the code is causing so little pain that they no longer want to pay my rate.
Right?
And we never get to 10 years. So when I get there, I will tell you. But usually, they're in a lot of trouble. You do little changes, and very quickly, you get into a place where it's just bad code. bad code is infinitely better than horrible code. I will tell you, you can get to good code. It's just a question of waiting long enough. All right. So now we're up to 3 teams. We have sort of the middle team, we have the phone team, we have the WPF team. We're kind of, so we did this as a fixed price budget, and we're at the point where we're not losing money on this. But we're not making money on this, but it's okay, because we all know that once we get it to our customer, we can then sell it to all the other customers, and we're just going to make tons of money on that. And so it's all good. We're using Microsoft Project to do this, and it's sort of tracking all the different things that you have to do and telling us as we're getting closer and closer to done. And we are almost done, which is really quite amazing, because this project is now getting a little long in the tooth. And we're at like 95% done, which is fantastic. And in fact, Microsoft Project is actually telling us that it's just 2 weeks. Why are you guys laughing?
Experience of Windows progress bars.
If you mention Microsoft Project, what do you want?
So this part might sound a little familiar to you then. So when we are done, we just have to get the team stuff to work together. Yes, and which is only 2 weeks, it says in the thing. There was none, but it wasn't 2 weeks. It didn't fit together quite the way that we were planning, and it wasn't, so I thought it would be like, hey, like my TV. Like I have these 3 things on my TV, and there's the wires, and they're color-coded, and you stick them in, and it works. And I thought, well, maybe if it didn't work, it'd be like I had 3 things and only 2 wires, right? But what it turned out is that I had like 5 wires and like 4 holes, and it was supposed to do 20 things, and so I can't remove this one, but I can't add this one. And so this went on for a while. And what bothered me is everyone was laughing at me then, too. Like I should have known that project was just going to lie to me. People would say stuff like, the first half takes the first 90%, and the second half takes the last 10%. So I felt like I felt duped. Like everyone knows that this is a big old lie, and yet, we're still committing to it. Yeah. This took a long time. This took a really long time. So what was the mistake? Don't say Microsoft Project. We're in their house. So if we had prototyped our thing, then things would have worked well. So what is the thing that didn't work well? So if I did integration testing, then perhaps things would have worked well. But what did not work well? Integration. Integration is the problem. So I got these tools available to me. What's going to make this cheaper? All right. So we have a thing called continuous integration. It's about detection. It turns out it's also about area of effect. There is a correlation to when you just wrote one thing, it usually only touches one thing. It works for both. So continuous integration. If you do not have an automated build, what you do not do is you try, like what I see a lot of times is people don't have an automated build, and then they try to make continuous integration. That's a very painful thing to do. What you do is you build an automated build, and then you put that into continuous integration, which literally just says, push the button when someone checks in. Right? But if you're trying to build the button and push it, it's much more complicated. Source control, please tell me that this is just utterly redundant in this crowd. But this fair amount of companies that I have worked for do not have source control.
No.
Good. So totally redundant here. Good. Yes. Yes, very sincerely. In fact, I even know of departments at Microsoft that still emo code around, that projects you probably used. So those two things, I really want to talk about killing the messenger, because this is another really common thing I see at a customer site where they're like, oh yeah, we have continuous integration. And I'm like, oh, it's not running your tests. Oh yeah, they used to fail a lot. We turn them off.
Yes.
So when your tests fail, just turning them off doesn't make your project better. It's not the same thing. All right, so anyhow, we do get everything integrated. We get everything together. Project is going pretty good. I mean, pretty good, that's not the right word. We're sufficiently over time, we're over budget. We're losing a little bit of money, not a lot of money, but a little bit of money. Maybe a lot of money. Our team is bigger though, you know, that's good. It's always good to manage more people, right? That's okay, because now we're actually at the end of the project. Right, this is a good day. We have the final thing, we're good. We send it off to QA, just to make sure, you know, everything works. And QA comes back with like just amazing news, because we are awesome programmers. And they come back and they tell us that there are only 10 bugs. That is nothing. We go drinking. We knock out those bugs in 3 or 4 days. And we send it back to QA. And they come back again. Still with awesome news, 5 bugs. Okay, so 10 bugs is nothing. I have half of nothing, right? It's no problem. It's like another 3 or 4 days. We knock out those 5 bugs. We send it to QA. They come back. This time it was 6 bugs. It was weird because I guess there were some parts of the thing they couldn't see because of the other bugs. But it still doesn't matter. 6 bugs is nothing. So we knock those down, and we're done at the end of the week, and we send it off to QA. And they come back with only 4 bugs, which is, I mean, really, really close to nothing, right? So, you know, we're done at the end of the week here. And the only weird thing is, like, now we're 4 weeks into being done from a week, and the customer was kind of rolling their eyes a little bit when we're talking to them. It's not a big deal. Like, so anyhow, we knock out those 4 bugs. We send it to QA. They come back with another few bugs. Still, I mean, really, it's under 10 bugs. I mean, I can't even tell you how close we are to done on this project. And so we fix those up, and we send them to QA. And they come back, again, another few bugs. This time, our bosses are rolling their eyes a little bit. We're still drinking, by the way. So this goes on for a while. Sort of like, I think somewhere around the 10 or 12 weeks of this being 1 week away. Some of our better developers went to projects that were more fun. But that's okay, you know, it's still, I can't even tell you how close we are to done. Yeah, so there's actually a phrase for this, it turns out. 6 bugs away from production for 6 months. So, what was the mistake?
Lack of unit tests.
That would have prevented the mistake.
Not getting done frequently.
Breaking, what is breaking code called? No, that's what non-breaking code is called. Bugs! Our mistake was bugs. If we didn't write bugs, this would have been awesome. So how do I make that cheaper? Detection is really the big thing here. So let's do a scenario here. This is 8 o'clock in the morning. It's a little bit of a lie, but let's say at 8 o'clock in the morning I come to work. And then I code all day. And I write a bug somewhere in the middle of that, just one. I'm a good programmer. And then I end my code. And then it goes to QA. So if I wanted to make this cheaper, what do I have to do? Yes, so this is where a lot of people go.
Yeah, you could go even.
Keep going.
But you can go cheaper.
Keep going.
Yeah, yeah.
So right there would be good.
And even earlier.
That would be awesome. But if I want to detect that my bug happened here, where does my test have to exist?
Before everywhere.
Right here.
You can finish it over.
Exactly. department called Tester and Development. It is about detection. I'm going to give you a really small demo on it. But first steps, and this is something, by the way, I see almost nobody doing. So, like if you listen to one thing and change behavior because of this talk, like write your steps in English. It's an amazingly powerful technique. Anyhow, here's my little demonstration from this project. First we're going to make a new order. And we're going to buy 10 shirts at $100 each. And we'll set the sales tax to 10%. And we're going to verify the order total. See how quick that was? That's about how long it should take you to write tests. That's only half of it, to be fair. I now need to translate it. So first I new up an order. Then I add some items. I'm using the C# syntax right here that allows me to preference what these are. I set my sales tax to 10%. And I check that the total is now 1,100. And this is really easy code to exist because it doesn't even compile. This is before I have any objects. So it's super simple. You can delete the English now. That's about how long English should survive in your code. But the writing of it is important. That's a whole nother talk as well. All right. Eventually, we do actually get the bugs done is not exactly right. We get it to an acceptable level that we no longer care. And we give it to the customer. And they start to use it. And it does everything that it needs them to do, but it doesn't do it necessarily in the easiest way. But that's okay, because we have some trainings. We put together some training courses, and we go out to the customer sites to sort of train them on the software that we built. And that's good too, right? Because they pay us for training, which is cool. But it doesn't stick that well. And the sites actually are really struggling with the software. In fact, there's even talk of some of the sites that have gone back to paper, which is really kind of ugly. And it wouldn't be such a big deal, because honestly, we get paid for the project either way. But the problem is that we're now a bigger team and more time, and so we didn't really make money on the project. We kind of lost money on the project, but it's okay because we can sell it to other clients, except for these people are talking, and that makes it really hard for our salespeople when they show up and say, would you like to buy this product? But that's okay. Like, they are diligent and they try, and they really do. They try very tough for 2 or 3 months before they finally give in and throw in the towel and just say, we need to kill this project. Like, we're not going to be able to resell it. We're not making money on it. Just to be very clear, this is not the Ken phone. But we scrap the product. It ends up dying. So what was the mistake?
Bad usability. Taking the the first time?
Possibly, actually. But again, that would have prevented the mistake. What was the mistake? Well, we got it done.
Bad design.
Not getting it done.
Not getting the customer to buy in as a partner. They have
It was not done. It was not me.
you didn't take the customer's drink.
We didn't get the customers to drink. So if this went well, right, the customers would be happy. They would be celebrating. So what was wrong is we didn't make something that made the customers happy.
They have the right product.
We built something the customers didn't like. Had we not done that, we would not have all these problems. And you're telling me ways to not do this, but first we just have to acknowledge that we're going to do this. So, detection. All right. So this brings us to what is probably the most common. Most common of the Agile practices: iterative development. It is about detection. Reduce your scope probably to 2 weeks. If you're having trouble with 2 weeks, go to 1.
Yes.
Don't go to 3.
Exactly.
It's the wrong way. Common mistake is partial work doesn't work. I want to really put this in perspective. Like, if the customer is not using it, it does not count right? You have demos. This sounds a lot like OnSite Customer. If you don't deliver, it is exactly OnSite Customer. You need to deliver. Big things happen when you deliver. The Pepsi challenge that inspired New Coke, that's a non-delivery. That's a sip test versus actually sitting with the drink and drinking the whole thing. I think of this like having my parents choose my dates. My parents love me. They know me. I do not want them choosing the people I date. There's a different mechanic at place when you are the one living with it more than you are the one saying other people should live with that. Partial work doesn't count. You have to deliver. When you deliver, two things can happen. One is the guy in the back who said, you shouldn't have taken this contract in the first place. That's a very real possibility. And it's something you'll hear people in Agile talk about in a positive light. They'll call it failing fast. It's weird to talk about failing in a positive light, but if you're going to scrap a project after 18 months of development, $3 million on the line, it's better to scrap it after 2 months of development and $50,000 on the line. This is a net win. But it's not the only option. The other option is you can steer. And steering works like this. Let's say I have an idea. I want to get to Nancy. Nancy, can you raise your hand so everyone knows who you are? Now, what a lot of people will do is they will say, Nancy is in this direction. And then they will start walking. Hello, Nancy. This does not work well. So the alternative is to steer. Where I start walking and say, oh, Nancy's over here. Now I can walk over here and say, oh, no, wait, Nancy's over here. Walk over here. Oh, wait, Nancy's over here. Oh, wait, no, it's over here. Oh, wait, it's over here.
Yeah.
Oh, wait, it's over here. Kaboom.
Yes.
And the precision I need to get it right on the first place is greater than I can get. But with steering, it's very easy. So I want to give you a really quick demo of what it's like to steer a project. Here's my project. I talk to my customer. He has some requirements. He needs 2 small circles in the center. He needs a line at the bottom. He needs a rectangle around everything. So first I have to have the conversation with my customer where I say, I can't build this all for you. What's the most important? And they will say, it's all the most important. This goes on for a while, but eventually we get to the point where we say, okay, we're going to do just one thing. Maybe I just start with these 2 small circles in the center. I say, well, that doesn't really even make sense until you have the rectangle. You can't do anything. There's no center. All right, well, can I do the rectangle? Yeah. So I go and I build the rectangle. And they say, you know, it's kind of harsh. Can you just soften it a little bit? And that's not a problem, because A, I just wrote it, so it's kind of fresher in my mind. It's not really connected too much right now. I can round it and get it to them, and yeah, okay, that's better. Good. Maybe now we can work on the center, so the circles at the center. Cool. So we go and we build that out, and we give it to them, and they're like, yeah, it's kind of familiar. Maybe you can separate them a little bit, lift them. So we can do that. We give it back to them, and they use it, and yeah, this is good. Maybe we can do that line at the bottom. Yeah, no problem. It's curved line. The other way. Curve the other way. Now, everything I did originally filled the requirements. Both of those systems fill the requirements. But this is the difference between software that fills the requirements and software that makes the customer happy. And that's the power of being able to steer your project. So I've been going on and on here. We talked about 6 of the main practices. There are many more practices. But OnSite Customer, Pair Programming, Refactoring, Continuous Integration, Test-Driven Development, and the most common of all, Iterative Development, a lot of times just referred to as Scrum, as that's the main part of Scrum. All of these weren't not just talks, but big areas of learning. I just wanted to give sort of the overall case, why we do all of these. And there's many more that if you take the same thing and apply. I was talking just earlier, and we were talking about retrospectives. And I said, you know, I'm not going to talk about retrospectives in this story, but if I were, the story would continue on as we repeat this process in the next process. Right? You make the mistake the first time, it's excusable, but when you don't learn from it, make your things cheaper. If you just follow that principle, you will discover all of Agile. Except you'll make the mistake. Except that you can make it cheaper. Move on. Thank you. So, first of all, I imagine there's people with quite a lot of questions. So I want to give the people who did not want those questions an opportunity to sneak out. But, any questions?
Wondering in terms of, like that first mistake number 1 or 2, that you needed to do the purchase order.
The purchase order, yeah, the very beginning, where we misunderstood what the requirement was.
Yeah, I mean, certainly the earlier detection, the better. Even at that point, well, first of all, the sales said, not a problem. There also have been well, of course the sales guys, but let's say, we'll do that. That changes the scope of the project, and we're going to renegotiate how much it is, and maybe the customer says, no, I don't think it's that important that it's a change. Or they say, yeah, and then you have the money for it.
So the money for it question, I mean, in the end, whether we solve that problem by just allowing us to work longer, we end up in the end result of, have we now built something the customer doesn't like, right? And so there's always this inherent problem in fixed price bids where someone has to win. Like the way fixed price bids work is there is this point in the middle where the customer is spending exactly the right amount of money for the amount of work we're going to do so that we're profitable. And the idea is that you're going to hit that point. And if you do, everything's good. But if you don't, one thing will happen. Either the customer will lose. They paid $100,000 for something that should have cost, $2,000. Or you lose. You were supposed to make, $50,000 on this bid, and now you've lost money, or you only made $2,000. Like, someone has to lose. Because unless you get it perfect, you are not trading the right amount of software development for the right amount of money. It has been my experience that even when I'm on the winning side of a win-lose contract, I end up losing. That the way I get really good results is I'm in a win-win situation. And the reason those are good results is because they allow me to continue, right? Clients where I have a continuing, ongoing relationship, those are better clients. They produce more, they have less overhead. If you set yourself up so that someone has to win and someone has to lose, usually the end result is people stop playing. So you can set it up so it's more likely you'll win, but you still end up in the bigger problem. Does that make sense? Yeah.
Your development questions, going back to your sales system. I've been involved in projects like this, but I'm asking, it's a big thing.
I'm so sorry to hear that.
And you need a certain amount of functionality for them to be able to do a reasonable test on it. You can't produce it in 2 weeks. How do you solve that?
So the question is, how do you get something that's usable in 2 weeks? Right? Because obviously it's not going to be the whole system. And it's surprising how often we think we need things that we don't. I'm going to tell you a story. So, yeah, I didn't introduce myself very well in the beginning, but one of the things that I do is I'm a co-founder of a charity to teach kids to program. Speaking of which, if you have kids of your own, we just came up with a free course on Pluralsight to teach your kids to program in C#. We also have courseware in Java. Teach your kids to program. It's really important. Plus, it's awesome because I have like a 14-year-old stepdaughter. And kids don't always appreciate you that much. But they also usually don't appreciate what you do, and most of that is just honestly that they don't understand what we do. Right? Like when a kid's 6, they want to be like a fireman or a policeman because they know what those people do. Right? When your kid learns to program, they have an appreciation for you that you won't get that often. So, if for no other reason, it's a good reason to teach them. Sorry, so how do you break things down? So when we were working on this project, we wanted this thing for the courseware where we could see the screen of every kid while they were working, because it makes it much easier for us to teach the kids if we know what they're doing. We're in Denmark, in Copenhagen, doing a DigiGirls, which is a teaching girls to code thing for Microsoft. And we said, it's really easy to take a screenshot and save it to the file system. It was code that I could write, I think I wrote it in 2.5 hours. And it was a complete hack, right? But it allowed me to survive the next day. And I knew what I wanted that system to look like and how it would connect to the internet and how I could do it from anywhere and track. And it was another 2 years before I even started to write that system. Because that stupid little hack was really sufficient to get me through my teaching for the next 2 years. Over 150 courses, totally sufficient. Something that I thought was almost like useless to write. I wrote it because I just wanted it the next day. And it replaced a system that was much more complicated, much more involved. And a lot of times that happens. When people think they need these big things, but they really don't. They need simple things. And the best way to find out what those things actually are, better than anything else you can ever do, is sit down and do the job of the person you are automating. We are programmers. What we do is we automate stuff. Everything we do is automation. Even the things that have never actually been done, we are automating, right? We are saying, in this situation, you're going to do this. I can program the program to do that. And so we automate. And if you're going to automate something, do the job a little bit. Sit down. If it's an accountant, sit down at the desk and have them tell you what to do. If they're working on a factory line, like sit there and figure out what they're actually doing. And it's surprising. You as a programmer realize you can automate everything. So you'll be like, oh, you don't have to retype this from here to here. I can just parse that out of it. They're like, you can do that? Yeah, they don't think that way. If you are expecting them to come and tell you that, it's going to be much harder. And they're going to tell you sort of the big picture thing. But if you sit and do their job, you will really quickly realize, I can do this small thing that will provide value and make them happy, and you can get it to them, and then you iterate. Right? The first time you give them something small, there is a lot of resistance. When you come back 2 days later and give them something else small, there is still resistance. When you come back 2 days later, they're kind of happy to see you. And then when you come back, and then like a month later, like you never have that conversation again. Sit down, figure out what the small thing is, and then immediately follow it up. If you give them something small and don't talk to them for another month or two, now they're not going to want to give you small things again. Does that make sense? Kind of? Yes. Enough to not pester him.
Fake it.
Fake it. Yeah, fake it till you make it. So, so this gets into a very interesting part of Agile to quite an extreme. So there's an entire area of Agile called Lean Startup, which if you're not aware of, go check out because they're doing some really interesting things. Lean Startup says, I'm going to make so many mistakes I can't even count. Right? I'm going to make mistakes so frequently that like when I put this button here, it's probably wrong. And if this button is probably wrong, I'm not going to write the code behind it. I'm just going to wire up a thing that says you pressed it. And then I'm going to look back and see if you did. And if you did, then we'll talk about me writing it. Right? So, like, so that's, I mean, this is an extreme form of faking it, but it's actually quite good. In fact, I heard a really nice thing from Ken Beck on this, where when he first put the buy button on his system, right? So you have to buy, and people like put in their credit card information to do it, and he just put a blank form so that if someone hit the buy button, they got it for free without the card being charged. He's like, it was really cheap to do, and only 6 people ever did it, so it cost me like $12. It was like, you know, had people actually used it, then he would have done, you know. But you can do these kind of things. In the lean startup, you should be doing these kind of things because you are trying to discover, like if you're doing a startup, the idea behind it is I want to do something that doesn't exist right now that will change the world in some sort of profound enough way to make me money. And the idea that you're going to get that right the first time, it's really just a lot of good luck on that one.
One example people can try today is webwhiteboard.com. It's exactly exemplifying this.
You can just put it together in demo.
No, it's a working website, but if you select one of the pull-down menu items, it comes up with how important is this feature for you? Would you be willing to pay for this feature?
Nice. And I think actually the best example of lean startup in motion today, which is just phenomenal. And if you're not aware, like our entire world kind of shifted about 2 weeks ago right now with the advent of Veronica Mars. So do you guys know what the story is?
Yep.
Not enough of you know about this, so let me so okay, here's the deal. So there's this company called Kickstarter. You probably are aware of Kickstarter. So Kickstarter is the best idea of lean startup. Lean startup says, will you pay for this feature before I build it? Kickstarter says, like, will you actually, not just will you pay, like, give me your credit card, and if we get enough of them, we'll build it. And this little startup company called Warner Brothers, they're a small $70 billion company. They make films, but they decided maybe we should try this new thing of making a film. So they put up a Kickstarter project to say, hey, we need $2 million to fund this film. And people waited almost 23 hours before they gave them $2 million to fund it. Yeah, so world changed as that happened. Companies that are stinking rich and have a lot of money and make core concepts can now get them funded by the little guys. This is like Microsoft doing a Kickstarter project to make a new version of Office. And it's succeeding. Second, it strongly questions whether or not you ever even need a company like Warner Brothers. So on the one hand, Warner Brothers is doing quite well by this, but on the other hand, they are literally threatening their own existence, which I actually like. I like companies that disrupt themselves. That's pretty awesome in my book. Nonetheless, Kickstarter is exemplifying this idea, pay for the product before it even exists. And if enough people do, then it's good, and if it's not, then don't build it in the first place. It disrupts VC money substantially. It disrupts a lot of things. Another very interesting thing, also through the Kickstarter, is the Amanda Palmer TED Talk that just came out. If you haven't seen that, that's worth adding to your video list. All right. I think we might be at it. Oh, we got one quick.
Yeah, you talked about your hack. And anytime I hear hack, I go, well, my architecture's not going to improve. So I guess how do you manage that risk and kind of get through that hurdle?
Okay, so the concept of the architect. So, okay, so I've actually seen this. I've seen this on business cards that you're an Agile architect. I do not know what that means. But I would argue that the architect is inherently an issue, right? I've never seen architects produce an architecture that is actually adhered to create a good product. What I've seen is architects produce an architecture that is loosely adhered to, usually to create not such a good product, because the devil is in the details, and it just gets to that point. So your question of how do you deal with the architect who is blocking you? So I'm really good at technical problems, but this is not technical. This what you just described is a people problem, and you can ask around. I'm not so good at this. So I don't have a good answer for you, but I do know that the answer isn't technical. What you're looking at is a political and a person problem. It's probably based on trust or just desire to keep your job. I mean, there are forces at play that are, I don't want to say harder, but much more on-off, arbitrary, at least from my view, they look arbitrary, in play. And I unfortunately have no good advice for you. But there are people in this room who are awesome with people, and they probably can help you. So the question is, how do we do architecture? And the answer is it evolves, right? So we keep awareness in our teams very high. We mob. People familiar with mobbing? So mobs usually 5 or 6. We keep our teams small. We keep them autonomous. So we have good walls between them. And as we realize that things need to change, we add them in. We keep unit tests so that we can change, right? One of the things is that when things, like one of the big problems with a lot of companies that do Scrum is they say, hey, let's stop planning, and we'll just respond to change when it occurs. And that's precedented on the idea that existing code is really easy to change, and that's not the way that our experience really tells us. So when you do that, what happens is a lot of times you get yourself in a place where you're like, now we need to change, and people are like, I can't change that code, and now you haven't planned, and you're stuck. That's not a good thing. Like, you need that ability to react. You need that ability to change. You need to say, Scrum says we're going to make mistakes, don't plan, but you need to then say, we're going to make mistakes, they need to be cheaper, right? Which is one of the reasons TD is such an important practice. Because a lot of times, your ability to do anything else gets hampered. If you cannot change the code, all the other practices don't matter. Okay. So, that's what. Oh, we still have one more? Okay. Yeah.
Okay. You mentioned during one of your slides that you're having trouble with 2-week iterations, that you shouldn't go to 3.
No, you should go to 1. Yes.
Go to 1, exactly.
And
Exactly.
we all agree. Well,
We all agree.
Could I just get a little bit of more background information about why you would go to 1 instead of 3?
Right.
Other than failing even faster?
Well, no, so failing faster is part of it. So, let's say that you're having trouble balancing a budget of $1 million, right? So you come to me and you say, hey, I need $1 million. And I'm like, well, last time you didn't meet your budget of $1 million. Your fail is good. It would be very weird for me to say, but you know what? This time I'm going to give you $4 million. I think that will solve the problem. You didn't do good with $1 million, but $4 million, I bet you could rock the park with that. It's just crazy, right? You'd say, okay, let's go back to 50,000. Let's see you do good with that, and then I'll give you more. Your iteration is your budget. It is saying, how big of a chunk can I take and succeed? If you're having trouble with big chunks, smaller bites, not bigger bites. In fact, so there's a mobbing video out there. I suggest you watch it, but they rotate at 15-minute increments. That is very advanced for a mob rotation. I would suggest something closer to 5, right? They're good. They've been doing it for a long time. They're advanced. They can take longer steps. If you are having trouble driving at 120 miles an hour, I would suggest going to 60, not 180. If you're having trouble, reduce the size. Don't increase it.
Just a comment on that, not an additional question. I think a lot of folks who have trouble with the idea of 2-week cycles are really struggling with the overhead involved, trying to get the cycle to close or the cycle to open. And so making it shorter actually amplifies the problem, not reducing the problem, for the overhead aspect.
Right. Okay, so here's a story from Taitiano, which if you haven't read any of the stuff from Taitiano, he invented our whole field. His stuff is not that consumable, but it is really brilliant. And this is one of my favorite stories from him, is when he first got to Toyota. So this is way, 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 way back. And there was this guy who would put the bumpers on cars. The bumpers nowadays, they're all very fancy, and you don't actually want to hit the car because it breaks them. But in the old days, bumpers were actually meant to bump into the car. And so the way it worked is the car would come, and it had these 4 bolts. And this guy, who was like a sumo guy, right, would grab the bumper from the stockpile of bumpers. Right? He'd grab it. He had a particular skill of being able to match the bolts in the holes because they weren't exactly precise, right? They're hand drilling. And so he would grab it and he would put it, and it would almost fit in the car, and then he would sort of whack it in and get it into place. And so Taichi Ono sees this, and he goes to the guy and he says, what happens when he's sick? And they're like, oh, he's like, the whole plant like basically shuts down. He's like, it takes 3 guys to replace this one guy, right? Like, none of the guys can handle holding the bumper by themselves. They have so much trouble getting out to the car. And so Taichion is like, this is a problem. And he says, well, the first problem is the guy is good at picking out which one of the 20 bumpers fits with the cars. So he said, I'm stopping that. So he made it so that instead of laying the bumpers out, the guy got the next bumper in line. And he just had to make do with the bumper. And this is not a good thing for the factory. This slows the factory right down, because the reason that was working is because the guy could figure it out. So with that restriction, the factory is in a lot of pain, and they decided they need to standardize how they drill those holes. So it no longer mattered. Right? And that was the start to replacing this one guy with actual normal workers from Japan. You don't minimize the pain. You actually increase the pain so that you fix the pain. Analogous to this, I have a tendency not to go to my dentist until I'm actually in pain.
What?
Right? For some reason, people don't fix things until it really hurts. So, yes, if you're having trouble with 2 weeks, you go to 1 week, it's going to hurt more, and you will fix the thing that actually is causing you pain, and then you'll get good. And then when you're good, you can go to 2 weeks again. But a lot of times when people get good, they no longer want to. But you can.
Sorry, the manufacturing, people use an analogy for that of from Japan. You lower the water level in the lake, you see rocks.
Yes.
You get rid of those rocks, you get rid of those, you lower it again, and by the end of it, there's no rocks, and everything is still sailing.
Yeah, nice.
That's a good analogy.
Well, thank you very, very much. I think